In part 4, we're ready to start making some sawdust. I have the sheet of plywood up on the bench, my cordless saw, spacer blocks, and 8-foot straight edge. These are going to be long, rough cuts, slightly oversized, which will then be cleaned up on the table saw. Here are my dimensional prints for the top, shelves, and sides. I also have the print for the toe kick, but it will not be cut out of this sheet. Before cutting, I have to get the blocks under the sheet. Now I have the sheet spaced up off the bench and marking where the first cut will be. I have the saw blade all the way up with the blade aligned on top of the cut line. I put a square up against the saw base plate and mark where the straight edge will be clamped. Now move the straight edge over to the line and then measure to the edge of the sheet. It is 14 5/8 inch from the edge, so now I set the other end to the same distance. I go back and forth a few times to ensure both ends are at the same distance, mark the factory edge that I know is square, then clamp it down. Double checking all the measurements and then make the cut. After this cut is complete, I mark the board so I know what parts these will be. In this case, these are the sides. The cutoff for the sides was removed and the board moved over and now setting up for the second cut for the shelves. This will be an identical cut as the first one, but this time I'm using the factory edge of the first board as my straight edge. Since I slid the board over, some of my spacer blocks needed to be repositioned so that the cutoff and remnant are both supported along the cut line. This second board is for the shelves, so using a rough measurement, I mark each of them by writing shelf on each board. Rummaging through my cutoffs, I found 2 potential boards of 3/4 pine to be used for the toe kick and another remnant of a plywood sheet to be used for the top, leaving this long remnant board for the next project. Now setting up to rip the board for the top from the old remnant using my 4-foot saw guide. This is a 4-foot straight edge that I use with my small cordless saw. It is 5/8 plywood on top of 1/4 inch plywood, and the edge of the 1/4 plywood is the actual cut line. That's it for the sheet of plywood, and now to figure out which one of these boards I will use for the toe kick and cut all of the other boards to size on the table saw and crosscut sled. Examining the 2 boards for the toe kick, I am looking for knots, any physical damage, and grain direction. I would accept that a knot is in the middle of the board, but not on the cutting edge because it makes it difficult when finishing with a plane, so the short board is out. The longer board does have a defect that must be avoided, as well as a small loose knot. The knot is not within the cutting length, so I think I found my board. On the crosscut sled now and cutting the 2 sides from one of the long boards. If you don't have a crosscut sled, trust me, you want one. Here I am showing one method I use to control tear out from cross-cutting in plywood. Mark your cut line on the bottom of the board and then using a razor knife make a cut just to the inside of the line. This cut, if in the proper place, will stop most tear out. If you've been watching closely, you'll see I always try to measure twice before making a cut. Flipping it over after the cut, you can see there's hardly any tear out, and now to repeat the cut for the other side. I mounted my table extension to accommodate the longer board and have a stop clamped in place for cutting out the shelves and top. I am not concerned about tear out because these ends will be hidden in a dado. I am first going to make a kiss cut on the board and confirm it is the right length because this is critical to get all of the shelves out of the longer board. Using my edge line transfer tool to extend the line from the face to along the edge so easily sighted against the blade. Using my dinking hammer to make adjustments equivalent to a few thousandths of an inch at a time. I pay close attention to setup when I will be cutting multiple boards the same size. One error here results in multiple errors. It is wise to avoid the practice of never time to do it right, but there is always time to do it twice. I am using the shorter board for the setup since if my math is wrong, the longer board may not be long enough to get all of the shelves. If this occurs, then I would need to make all of them shorter and this one would be the last board to cut. Now with the longer board on the crosscut sled and I almost immediately screwed up the first board. I forgot that when using the crosscut thread, the table saw needs to be set to the other end of my 4x8 workbench because this side is just a little bit taller and the sled will not go over it. Now the table saw is set in the right place, and we'll see if I can get it restarted without damaging the cut. Perfect. Now we're about to find out if my math was correct and all the shelves can be cut to the design length. I'd have to say, not too bad. This is an efficient use of the plywood sheet. And now to go back and trim that last board to the design length. I decided to face all the visible plywood edges with pine. I have already ripped a number of pieces at about 1/4 inch thick and now using an 8-inch sanding disc on the table saw to smooth one side to get a proper finish for glue joints. After the first pass, we can see how most of the cut marks have been smoothed out. One more pass and should be ready to glue. Here is one method I used to prevent the glue squeeze out from contaminating the face of the board. This is something I do when a project is going to be stained, especially with open grains like oak where the glue could fill in the grain and affect the stain quality. Glue tape is applied and then trimmed with a sharp knife right at the edge. Any squeeze out sits on top of the tape. Although I used these band-type clamps, I would not recommend them due to the price. In addition, I have 6 of them, and you will see later in this project that one band broke and they do not sell replacement bands. This time showing a method to make 2 clamps act as 3 when there is a shortage of clamps. Using traditional bar clamps, I have some 3D printed spacers that elevate the boards up off the bars. The metal of the pipes can react with the glue and can stain the boards. For edging, they serve as a spacer so that there is some of the edging above and below the joint to be finished later. With a backing board and a spacer in the middle, 2 clamps act as 3 since the backing board presses down on the spacer, acting as the 3rd clamp. That was a dry assembly run, so now to take it all apart, apply some glue, then clamp it up. All the boards are ready for preliminary finishing and now getting set up to finish the 2 faces and all the edging. This consists of matching the edging to the face and then we'll be ripping to final size. Also yet to be completed is the edging for the top end of the sides. First thing to do is belt sanding the edging so it is flush with the face on both sides. This is a rough sanding to be finish sanded later. We have to be cautious with the belt sander to avoid going through the first laminate of the board. Next is trimming the ends of the edging using a flush cut handsaw. The kerf on this type of saw is one directional with the intent that the other side is to be held flush to the board. These are pull saws and only cut well on the pull stroke. Very little sanding is needed when it is done properly. cut all the shelves and sides oversized, plus I added the edging, so now it is time to rip them down to the design size. The design size was 13 inches, so first checking the actual size. I measured all the boards and they are between 13.5 and 13 7/16 inches. First step is to get them all to the same size by trimming just a bit off the non-edged side. Now that they're all the same size, I go back and trim the edged side to make all the edging the same width. Using one of the boards for the saw setup, I mark the end of the edging at 1/8 inch. This is not a critical measurement and is only to make them all the same. I set the board against the fence and go around to the other side to confirm the saw blade is close to or touching the mark. Again, the only critical part of this is that all of the edging ends up the same size. Installed the feather board since all the boards will be the same size and start to ripping. Ouch! Big error here, not making sure the outfeed table was clear. A longer board ran into my finished boards, pulling it off the fence. Inspecting the damage, I find that it resulted in a significantly deep gouge in the edging. Since the board is not yet at its final width, I have a few choices. 1. Cut the edging a little skinnier on this board only. 2. Cut off the edging and replace it. 3. Make the edging skinnier on all the boards. I decided to make the edging skinnier on all of the boards just to be consistent with the design. Now it's time to get them to the final dimension, but first need to clean up the saw cuts on the edging. For this I use the sanding disc on my table saw since my jointer is too small for the width of a board. This will require 2 or 3 passes for each board, then, if necessary, tapping the fence over and then running them through again. When doing this, I must maintain a constant speed through the disc or it will leave a low spot. Now that the preliminary finishing is done, I use my 45-degree bevel sander to break the corners. Also can use a block plane to speed things up, but then must pay attention to the grain direction, then clean it up with the sander. Here is what happens with a conflict in the grain direction when planing right to left and gouging out the wood. Farther down this edge, there is a place where the grain changes directions and would cause issues if planing in the other direction. This is a closer look of the gouging that occurs when planing against the grain. The 45-degree sander will take care of this. The front-facing edges are all completed, but I still need to add an edge to the top of the sides to hide the plywood laminates. We'll also add a 1/8 thick face of tempered hardboard to the bottom of the sides. Years ago, when helping somebody move a piece of cheap furniture made from particle board, the outer lamination came loose when it was dragged along the carpet. They were not happy, and I just thought to myself, don't buy cheap furniture. I normally add a piece of hardboard to the bottom of things I build using plywood to protect the laminations. It also provides a smooth surface when dragging heavier pieces around. I am using polyurethane glue to attach the top edging, so also using the blue tape to protect the squeeze out from dripping across the board. So I apply the tape and then trim closely with a sharp knife. This is to prevent any of that expanding glue from getting into the face grain of the plywood. Since a rabbit is going to be cut into this edge, I chose poplar for the edging to avoid the possibility of the soft pine splintering during the cut. Poplar is just a bit harder and close enough to the shade of the board. I added some additional drip protection because if too much glue is applied, it will drip down before it sets, contaminating the grain. A little bit of glue, spread it around, a bit of water on the mating piece, and clamp in place. I was never a big fan of these clamps from that rock place. I purchased a set of 6 many years ago when they were heavily discounted, and this might be the 5th time I've used them, and now they are on my never buy again list. As you saw, the band broke and I was unable to find any place that sells replacement bands. The glue is set up, and now to finish it off. Most of the tape came off cleanly, and now using a block plane to take the edge down close to the face. I want to minimize the amount of sanding with the belt sander to avoid inadvertently sanding through the face laminate. Resting the heel of the plane on the plywood face minimizes the chance of the plane cutting into the face. I use a chisel to gently cut through the glue line and get the rest of the tape off so that it does not gum up the sandpaper. Flip it over to the other side, and this time cutting off the glue line with a knife, and then get a chisel to get the tape up a little easier. If you don't mind spending money on sanding belts, you may not worry so much about gumming up the paper. This is a low budget shop and I must save dollars every place I can. It is time to trim the side's top edges. My target thickness for the edges is 1/16 inch, so now this is the time to get them trimmed down. I will be clamping them both together, lining up the bottom and the front edge to enable cutting them both at the same time. Now I have the two sides clamped together, flush on the bottom and the front, ready to cut. I have a piece of blue tape applied to the push bar of the crosscut sled and then run it up to the saw blade to mark the cut line using a small square. I marked the top of the board where I want to cut and then line it up with the mark on the tape. Once I'm sure everything is lined up, I make the cut. It is time to attach what I will call the bottom skid plate to the bottom of the sides. For this I will demonstrate the use of a clamping caul. A caul is a board where the edge has been sanded or cut into a very large radius curve. Since this one is so short, I just sanded it down on a bandsaw to create the curve. Using only 2 clamps, the caul applies pressure across the entire joint due to the curved edge. In this demonstration on how it works, you can see when tightening the clamp on one end, it creates a space on the other, and when the other clamp is tightened, the pressure is applied across the entire joint. As you can see, this is much easier than using a bunch of edge clamps. I'm going to use construction adhesive for this glue up. It is cheap, very strong, with a long setup time, and it does not drip. I will only use this adhesive on unseen joints, or in this case where the joint would be hidden by the carpet. Apply boxing tape on the caul to ensure that it does not stick to the board. The nozzle of my glue cartridge is plugged up, so I poked a hole in the end to allow me to use as much as I can still left in the tube, but it does make it a little bit difficult to apply. I squeeze a little bit out, transfer it to a popsicle stick, then spread it on the skid plate. Now I position the skid plate ensuring that it is hanging over on all 4 sides and position the clamps all the way to each edge. Then tighten both and wait for it to cure. Now that the skid plates are attached, it is time to finish up the edges. This is basically the same process as before, but using my jack plane to make deeper cuts and then switching to the block plane for final cuts and then of course sanding. I finish by breaking the corner at 45 degrees. I finished the other side the same way, flush cutting the ends using the flush cut handsaw like I did on the edging. It is time to set up to cut the dados and rabbits. There is more than one method to cut dados and rabbits. One is a table saw with a dado setup, but these boards are too long to accurately cut on my saw. Another is using a router with a straight edge. The problem is that it is possible for the router to come off the straight edge, so I'm going to use my crosscut router jig, which at this point in the project did not exist, so I needed to build one. You should take a look at my crosscut router jig video to see how I put it together. I will include a link in the description. Now that my new jig is completed, I'm getting ready to cut the rabbit. Marking a line for alignment and use a combination square to align it straight on the board and then clamp it in place. Keep in mind, this will be the first time I have used this jig on a real project. I am making sure everything is lined up properly. Note: whenever working significantly off the edge of my carpenter's bench, I added clamp on the other side to make sure it stays in place. Too much downforce off the table can pull it right out of the bench dogs. And now for the moment of truth. Using a cutoff to validate the depth of the cut, and it is right where it's supposed to be. Now I'll cut the rabbit on the other board and then move on to cutting the dados. Now we are ready to cut the dados. First step, of course, is to mark the center point for each cut. To do this, I put a tape measure behind a clamp, enabling the spring pressure of the tape measure to keep it tight on the board. Then I run a combination square down the tape to mark each line based on my documentation. Now that the centers are all marked, I measure the offset for the dado jig. The paper in front of me is where I have it logged on what the offset should be. The other paper is the documentation I have telling me where each center line should be, using a rule and the combination square to mark each line. To avoid any errors, I double-check each mark and label which one is the center line using a center line symbol. To set the jig, I use the combination square and set it on the offset line, and then gently push the jig against the square, making sure it is centered on the board. Again, since this is the first time using this jig to cut a dado, I am double-checking that it is centered on the dado center line. With this setup, I can only use one clamp to hold the jig, so I use a load-spreading block on the bottom side of the board to prevent the clamp from leaving an impression in the board due to excessive clamping force. Another moment of truth coming, but at this point cannot be sure if it's exactly where it's supposed to be. I will not know that until they are all cut and I can make some measurements. Now that they're all cut, I pull out my 18mm dado sanding jig I made on my 3D printer. The width of the sander plus the paper is 18mm. Then I test the fit with a cutoff. Perfect. After I'm done cutting the dados and rabbits on the other board, it will be time for pre-assembly, sizing, and cutting of the toe kick.